In the last lessons, we learned the first features of Keras functional API, which allow us to use the same graph of layers to generate multiple models. The second features that I would like to talk about is the callable nature. Like the layers, with the use of functional APIs, we can now create a models, and then the models will become callable. Let's go ahead and dive into the detail. Once we create a model with the functional API, we can actually treat these models as layers. By calling out layers or by calling out models, we can reuse the architecture of the models and also use its weights. Let's go through an example. Let's try to create an encoders model that turns an image into a vectors, and then a decoders that turns that vectors into an image output to form a autoencoder. And what we're going to do, of course, is that we are going to chain these encoders and decoders models in two calls, and then to obtain an autoencoder models. Now let's take a look on the encoder models first. The first is that we have the input, which is, have the shape as 20x by 20x by 1. And what we are going to do is that we have these Keras inputs with these shapes of the image. And the names, we try to assign it as a original image. And this is the encoder inputs. And after having these encoder inputs, what we are going to do is that we are going to provide these encoder inputs into two convolutional layers with their corresponding activation functions, kernels, and number of neurons. So the first layer is the convolutional 2D layers with 16 neurons, 3 by 3 kernels, and with value activation functions. And this is the encoder inputs, and the outputs is an X. And then we'll pass on these outputs X into the next convolutional layers. This is the output X from the previous layer, and it will go through a convolutional to these layers with 32 neurons, 3 by 3 kernels, and another value activation functions. And then after going through these two layers, we will have a maximum poolings to these layers with a 3 by 3 poolings window to downsampling this image. And this is the X from the previous output, and it will generate an output for the next layer. And then it will go through two additional convolutional to these layers with the 32 units for the first layer, with 16 units of neurons for the next layers, and again 3 by 3 kernels and another value activation functions. And finally, it will go through a global maximum pooling to these layers to generate a vectors output. So it will go through these final inputs, will go through a global maximum to these layers and provide you an encoder output. And now we have the encoder inputs and we have the encoder outputs. We just configured the architecture. So now we are ready to put everything inside a models with the functional API. And the inputs, the first argument is the inputs, that is the encoder input, and the second argument is the encoder output. We also provide a name for these encoders, namely encoders. And let's take a look on the summary. And here we go. This is the summary. So just like what I mentioned, it will have an input that is a shape is 20x by 20x by 1 as an image input, and then it will go through two convolutional to these layers and go through one maximum pooling layers to downsamples the image or the outputs from previous layers, and then it will go through two more convolutional to these layers to learn the features. And finally, it will go through a global maximum poolings to these layers to generate a vector outputs, and that is a 16 by 1 vectors. Now we are ready to create a decoder. Once we have the encoders, now we are ready to build the decoder. We have the 16-dimensional vectors from the previous encoder's output, and we can put it as the input for this decoder input. So this decoder input will take these vectors as an input, and we will also call it as a encoded image to make sure we know that it's coming from the previous encoder's output. Now we can reshape these decoder inputs into a 4x4x1 dimensions, and then we will have a transpose, convolutional 2D transpose, which is to perform a reverse of convolutional functions to these 4x4x1 image. And again, we are going to have 16 and 32 number of neurons and 3x3 kernels, and with the activation functions value, and then these to perform these reverse convolutional 2D operations. And then what we are going to do is to upsampling these outputs from these these reversed convolutional 2D operations, and then after upsampling these values, what we're going to do is that we will go through 2 more reverse convolutional 2D operations, and then we will have these decoder outputs. And now we have the decoder input, we have the decoder output, and we also have just configured the architecture. So we can then put everything into this Keras functional API dot model. And we put the first argument is the decoder input, and the second argument is the decoder output, and we'll call it a decoder for these models. Now let's take a look on this decoder summary. For these decoders, it will take an vector input, 16-dimensional vectors, and then it will reshape and go through 2 reverse convolutional 2D upsampling, and then others 2 reverse convolutional 2D operations, and finally it will provide you a 20x by 20x by 1 image. So now we are ready to combine these models to form a autoencoder. Instead of stacking these 2 models together, stacking these encoders and decoders together, or we create everything from the bottom up again, we can just call out these models, because because we use the functional API, right now the encoders and decoders is a callable functions. So what we're going to do is that we set up the autoencoder input. That input is a shapes is going to take an image as an input with the shapes of 20x by 20x by 1. And then once we have this input, what we're going to do is to call out this encoder model and put this autoencoder input inside this. So now these encoders becomes a models, is a callable functions. Now we just put this input into these encoders, and this will becomes an encoder image, and then we will pass this encoder image to another decoders. Remember that we just set up these decoders models. So again, we can call it out, and these decoders becomes a callable functions. We just input this encoder image into these decoder models. And now the output will be a decoded image. Again, we can then set up the functional API, Keras functional API models, with the arguments of the inputs as the autoencoder inputs and the outputs as the decoder image. And then we will form a autoencoder. And here you can also see that this encoder is a callable functions or another functional models. And these decoders is also a callable functions. The models can be a nested models. That means a models can contain submodels, because a models now is just like a callable layers, or it's just like a layers. Common ways to use these nested features or nested models is ensembling. For example, here's how we can ensemble a set of the models into a single models that's with a average layers to average their predictions. The easiest ways for us to create these ensembling nested models is to create a functions and then repeatedly use these functions. And say, for example, we have a def-get models, and these models will return you a packaged models or a packaged result that will take in the input arguments and also output arguments. So, for example, for these input arguments, it will takes in a shapes of 120x vectors into as an input, and then this will return you with a dense layer with only one neurons as the output, and again it will return you these models with the inputs and output arguments. Now, because this model is callable, we can just assign it to a model 1, model 2, and model 3. If we have the input that is against with the shapes of 120x elements, dimensions as vectors, and this is the input for set it up as the Keras input. And now we have this input. What we are going to do is that we're going to pass these inputs into these models. So this model is a callable models, remembered, and so this input is the input. And then we will return you a y1 output. Again, for this we take the same input, and then it will return you a y2 output. Again, we will go through the model 3 with the inputs, and it will return you a y feed. And once we have these y1, y2, y3, everything will go through an average layers. It will average all these outputs as the outputs, and this is an ensembled output. Now, we can then create these models, and this is just like what I mentioned, this is like a nested models, because for these models, under this model, there's another 3 models created from this get model. Now, if we run this cell and then we take a look on this summary, you can see that under this model, there's 3 more models. And after going through these 3 more models, we will take the average. We will take the average by ensembling the outputs, and everything will be an average at last. Now, let's take a look on the final model architecture. So we take in the inputs, and then these inputs will pass on to 3 models in parallel. And then once we have all these values getting out from these 3 different models, or 3 same model in this exercise, we'll then use an average layers to ensemble the outputs. And that's it for these lessons. We just covered the second features, that is the callable nature, and showed us how we can use these callable characteristics to create different topologies. In the next lessons, we will cover more on how to use the functional APIs to create different graph topologies. See you in the next video. Bye-bye.